Good morning, students. Today we are going to see about Unit 5 in circuit analysis. The Unit 5 name is two-port network. So from 1 to 4 in circuit analysis, we see the various topics of both AC and DC circuits. For example, in Unit 1, we see the basic circuit terminologies, for example, impedance, resistance, etc. And for Unit 2, we see the various theorems used in AC and DC circuits. For example, superposition theorem, networks theorems, that is Thevenin theorem, etc. And in Unit 3, we see the resonance and coupled circuit. If it is how they are functioning when it is in self-inductance and how they are functioning in mutual inductance, that and all. And in Unit 4, an important unit called a transient analysis of AC and DC circuits. That is, we see the response from zero state to steady state response. So we see this different four types of unit in circuit analysis. So today we are going to see about your Unit 5. Your Unit 5 name is two-port network. So for your reference, please take your circuit analysis note and continue our speech. Clear? So let us see our topics involved in your Unit 5. The first topic is two-port network. Sorry. So first topic is two-port network. So take your note and continue, then only it can be easily understandable. So only seeing is not easily understand. So just take your circuit analysis note and continue. Clear? So the first topic is two-port network. Second will be Z parameters. Z parameters. Z is nothing but a impedance. Very good. And followed by Y parameters. Y parameters. And followed by transmission line parameters. It is otherwise called ABCD parameters. Transmission line parameters. Transmission line parameters. And we also called a general parameters or chain parameters. So let it be ABCD parameters. And followed by last topic in your that is parameters is hybrid parameters. So actually there will be a 6 parameters. For your syllabus, they are discussing only the 4 parameters. So remaining 2 is not there. Actually, the remaining 2 is inverse transmission line and inverse hybrid parameters. These are the 2 extra topics, but it is not included in your syllabus. And last 2 topic will be interconnection. Interconnection, that means how they are connected, how they are working when they are connected in series, parallel and cascaded. So interconnection of two-port networks. And followed by the last topic called symmetrical properties. Symmetrical properties of T and pi network. T and pi networks. So these are the topics involved in your Unit 5. The first topic will be a two-port network. That is, they gave the introduction of your networks and they're discussing the 4 parameters: Z parameter, Y, ABCD parameter and hybrid. So the hybrid parameter we also call H parameters, and followed by how they are functioning when they are interconnected. Interconnection is based on either it may be a series or parallel or cascaded. And the last topic will be a series symmetrical parameters. Symmetrical properties is nothing but the mirror image. One side will be the same as other side of T and pi network. So clear? So these are the topics we are going to discuss now. The first topic will be a two-port network. So continue. Two-port network. So just wait. I'll clear that. So it is one of the very important topic in two-port network. It maybe comes under 4-mark topics or it may be 8-mark topics. That is, they want to know the introduction. That is how they are involving in one-port network as well as two-port network. So clear? So now start your topic, a two-port network. Two-port network. This is your first topic in 5th unit. And generally tell me what is meant by a network. A network is nothing but a circuit having both active elements and passive elements. That is, it is having input process, then it gives a output. Clear? Like a system. It is called a network. And port. Port is nothing but a pair of nodes. Pair of nodes. We already seen a lot of concept in node concept. Clear? For example, in Norton's theorem, Thevenin theorem, they are based on the nodes, right? So port is nothing but pair of a node in which you can connect a voltage or current. In this pair of a node, in between the pair of a nodes, you can connect a voltage or current. This is called your port. So two port network is nothing but you are having two voltage and two current. That's why it is called two port networks. Clear? So first, generally real time application. So this fifth unit where it can be implemented. This this fifth unit can be applicable in three areas or three domains. The first will be the two-port network can be applied in a communication networks. So for both transmitter side and receiver side. So communication network is the first field the two-port will be implemented. And second will be, already we know that electronic power. This electronic power, that is your transformer, like the electronic power transmission and distribution. Transmission and distribution of electric power. These are the three important concepts in that is three important real-time application Unit 5. Clear? So let us see the first concept, a port network. So what is meant by a port? A port is nothing but a pair of a terminal. So don't forget the concept. This is the main thing. If you understand this concept clearly, you can able to understand the remaining concepts. Clear? So a pair of a terminal at which a signal maybe comes from either a voltage or current. A pair of a terminal at which a signal that signal may be voltage or current. Clear? Can be connected, can enter or leave. Enter or leave is called a port. Leave is called port. So this is a very important two-mark question. Define port. A port is nothing but a pair of a terminal in which a signal can enter or leave. So it can be explained by a diagram. Wait. So after seeing this diagram, you can able to tell the definition properly. So consider a black box. A black box is nothing but inside we can't know, but here it is having input and outputs. So consider this is a square box, name it as a port. Clear? It is having two pair of nodes. So that is a pair of terminal. That is nothing but a nodes. Node is represented by a single dot. So here see this one. Clear? And this will be called it as a first dot. That is first node, and this may be a, because both are will be in the left hand side, so name it as 1 and 1 dash. If it is having another 2 dot, we can name it as 2 and 2 dash, because the 2 dot present in the right hand side. So this is your 1 and 1 dash. So let it be the, what is the definition? A port of terminal in which a signal, voltage or current. So voltage can be represented by plus minus V, voltage. Yeah? And current, one will be entering current I, and another current will be a leaving. In order to see the differentiation, you can take it as I and I dash. Clear? This is called a port network. A port having a two dot, and that is a pair of terminals in which in this terminal we can connect either a voltage or a current. Voltage or current. Voltage is connected like plus and minus, and current will be called as entering and leaving current. It is called a port network. So then this concept will be mainly implemented in three areas we already saw. What are they? One will be a communication network, that is sender and receiver. This is a one concept. And second application is electronic transmission, that is your electric power consumption from transformer to your area. And distribution is from area to your home. It is called your transmission and distribution. These are the three real-time implementation of two-port networks. Clear? So based on the classification, based on the types, we can classify the port into two types. One will be a one port network, and definitely second will be a two port network. There will be 3 port and 4 port, etc. and so on. But as for your syllabus, a single port and 2 port network is more enough. Clear? So now what is meant by a one port and what is meant by a two port network. So one port is nothing but a square. Inside you can just mention it is one port. What about in two port? You just mention a square, name it as a two port. Clear? And now one port is having 2 dot and two port is having 4 dots. Clear? And this will be a line connected from dot to your port, and here the line connected from dot to the port and from port to the dot. So here it is having now we already saw that it is a V1, that is a voltage. We can connect a voltage. So here also V, here also V. Here only one voltage is connected, that's why we can use V. But here you can use two voltages. So let it be V1, V1 and V2. Clear? Then current. Tell about the current. One current is entering and another current is leaving. I1, I1 dash. And here the same. Current will be entering I1 and this side I1 dash. So don't put it as I2 because both the current entering and leaving in one side. That is for example left hand side. So mention it as I1. So definitely this current will be a I2 and this will be leaving current I2 dash. Clear? So these are the basic diagrams. Single difference between a single port and two port network. So let us see the difference. The important two more question is the difference between two port networks. That is single one port versus two port. So make a tabular column. You just follow in your notes, class notes. Clear? So this is one port. Difference between one port and two port is a very important concept. So the first one. So tell me the first point. What is meant by a single port network? So single port is nothing but how many dot? So it contains 2 dot. What about here? 4 dots. Dot meaning is nothing but a dot is represented in circuit as nodes. So here it is 2 nodes and here it is 4 nodes. And tell me how many pair? 2 node means 1 pair. So definitely it is 2 pair. A 2 pair of terminals. And what about the port? It is one port. Here it is one port. One port is nothing but one pair. Here it is a two port network. Port another name is pair. So this is must be a first point. So tell me the second. Give the diagram. Give the diagram. So above the diagram will be there. So give the second point as diagram. Okay. Then third point. The third point will be the connection. That is apply the KCL. So KCL, look at the diagram. Look at the diagram. The diagram will be I1. See here it is I1 and this is I1 dash. So as per KCL, what is a KCL statement? Your third one will be your KCL statement. Entering current will be equal to the leaving current. So see the third one, that this is your second, and third point will be your KCL by KCL. So KCL is having two statements. Can you remember? KCL is nothing but entering current is equal to a leaving current or sum of current in a node is 0. So as per KCL for one port it is called I1 will be equal to I1 dash. And what about your two port? You can tell that I1 will be equal to I1 dash and also you have to tell about your I2. So can you tell me the I2 equation? I2 will be equal to I2 dash. So these are the third equation, third difference. And coming to the fourth one. The fourth one, we can tell that fourth one will be a one port. If one port problem is given means you can solve by using Thevenin and Norton's theorem. Thevenin and Norton's theorem. And for two port, if the problem is comes on a two port network, it may be solved using S domain. S domain means what you immediately strike in your mind. That is very good. It is called Laplace transform. So Thevenin Norton's theorem, and here it is a S domain Laplace transform. So these are the four main difference between your one port and two port networks. Yeah. So the first difference will be a two dot one pair. Dot another name is node and pair another name is port. And here it is four pair. Dot means two pair. Second one, draw the diagram. So above the diagram will be there. So just draw the diagram. Third one, by KCL you can tell for one port I1 will be equal to I1 dash because entering current will be equal to leaving current. And what about in your two port? I1 equal to I1 dash and I2 equal to I2 dash. And fourth one, we can tell that if the problem comes under one port, we can solve by using Thevenin and Norton's theorem. And for two port, it can be solved by using S domain. Clear? So now we see the basic difference between the one port and two port networks. So now we can see the concepts. How the parameters is coming. History of the parameters. So see, listen. The two port network. So what are the things we immediately striking in your mind? Two port network. So the first point that is having two port, or we can tell it as a two pair of terminals. Very good. And four nodes. Four nodes or dot. Node is represented by dot. So these are the things we know. And what are the parameters involved? V1 and V2 voltage, and current will be I1, I1 dash, I2 and I2 dash. I2, I2 dash. So these are the six parameters. But as per KCL, we can tell that I1 equal to I1 dash and I2 equal to I2 dash. So totally involving parameter is V1, V2, I1, I2. Clear? These are the parameters. Okay. Sorry for the interruption. So these are the four parameters. V1, V2, I1, I2. So these are the four parameters. So four parameters we are writing as two equations. Four parameters, two equations. So tell me how many combination is possible? Four parameters, two equations. So combined as a two equation. Four parameter combined into two equation. Can you tell me what is the value of 4C2? Yeah, it is 6. How they can get the value of 6? So combination permutation you already saw in your aptitude as well as in maths. 4C2 means 4 into 3 divided by 1 into 2. So you are getting 2 and it is called 2. We are totally getting 6. So that is 6 combination of parameters. So that's why we are getting 6 combination. Out of the 6 we are having only 4 combinations or 4 parameters. Clear? So let us see what are the 6 combinations. Clear? Okay. The first parameter. So totally we are having 6 parameters. First one, second, third, fourth, 5. The first one will be a Z parameter. Z parameter. Z, what is meant by that? Z impedance. Very good. It is called open circuit impedance parameter. Otherwise called open circuit impedance parameters. And second one, Y parameter. So definitely if impedance is given, the second one will be a admittance. Very good. If it is open circuit, what is the name? Very good. Short circuit. Short circuit admittance. Short circuit. And third one, we call it as a ABCD parameter. Look at your syllabus. We are having the four concepts. ABCD parameter. Other name, yeah, very good. Transmission parameter or general chain parameters. So these are the third one. Fourth one will be your, yeah, last one will be your hybrid parameter. Represented by the letter H. Yeah, obviously. And fifth one will be your inverse transmitter. The third and fourth. Third will be a inverse transmission. It can be represented as A dash, B dash, C dash, and D dash. And the last one will be a fourth one opposite, that is inverse hybrid parameters. Inverse hybrid, let it be the letter G. G is going to be used for inverse transmission. Clear? Okay, now as per unannounced syllabus, you are having the first four. But while you are studying for any competitive exam, you can concentrate all the six parameters. So as per your level, four parameters is enough. So before involving into each and individual parameter, we first analyze each and every concept clearly. Then only it is easy, because at last we are remembering all the four concepts. It is make your difficult. That is difficult to remember all the four. It must be maybe collapsed. Clear? And one more, two more question will be that two more question will be there. The first one will be symmetrical network. Define symmetrical network, and second one will be a reciprocal network. These are the two important 2 marks present in your fifth unit. So symmetrical, we already know symmetricity. When we are studying the signals, the symmetric will be it can be reproduced the same. Clear? For example, actually the definition is if the network is divided into if the network is divided into two equal parts, each half is a each half has a mirror image. Each half has a mirror image. This is the main concept of symmetrical. That is, when we are dividing the network into two halves, it must be a mirror image. For example, see a resistor, and a resistor. And let it be 2, 2, 1. This is my network. If I divided the network into two halves, so take the first half will be like this dot. What is that? It contains 2 and 1 ohm. The next half, if it is divided like this, 2 and 1 ohm. So when you are dividing the equal half, it will be the mirror image. So but here see the same diagram, the same T-shaped diagram, but my value will be 2, 4, 1. So the first half will be, what is the value? 2 and 1 ohm, and second half will be 4 and 1 ohm. So it is not a symmetrical. So now you can get to and understand that what is meant by symmetricity and what is meant by asymmetricity. So if the symmetrical property is not obeyed, we simply call it as a asymmetrical property. So let it be asymmetrical. Okay. Then coming to the second 2 marks. The second 2 marks is a reciprocal network. What is meant by reciprocal? So have you heard about this word before? Yeah, it will be in the theorem, reciprocity theorem. If the network is reciprocity, if the network obeys reciprocity, we can tell it is a reciprocal theorem. If the network not obeys the reciprocal, it is called a non-reciprocal theorem. Yeah, if it is obeys. So definitely this will be all the passive networks. How they give? So we can give the example like this words. All passive networks are reciprocal. All passive networks are reciprocal, but not all the active elements. Active networks are not reciprocal. So all the passive networks are reciprocal, but all the active networks are non-reciprocal. So can you remember what is the difference between active and passive elements? Yeah, very good. Passive element is nothing but energy, ability of the energy to dissipate. For example, or if circuit only contain resistor or inductor or capacitor, it will be called as a passive network, and that passive network will be obeys the reciprocal network. Active element is nothing but source. So ability of a circuit to supply the energy to the circuit. Ability of an element so apply the energy to the circuit. Example, voltage source, current source. So this is the active element, and this active element must be a non-reciprocal because it definitely not obeys the reciprocity theorem. So these are the two important topics. So now you come back to the parameters, Z parameter and Y, A, B, C, D, H parameter. So clear? So now turn your note into a landscape because you are inserting a big tabular column here. So once you well strong in this tabular column, you can easily understand what they are going to be coming hereafter. Clear? Because all the topics will be based on this topic only. So take your note, landscape, draw a tabular column. Okay. So insert 6 columns. Once you see 6 tabular column, you can understand what they are going to be coming after. Because this tabular column has all the 4 parameters, including that symmetry property, reciprocity property, and then equation, who are the inputs and who are the outputs. So let us see the tabular column. Clear? The first one. Let's put 6 columns. So first one will be a serial number, parameter name, parameters name, who are all inputs, who are all outputs, what is the equation, and matrix format. Equation, matrix format, and reciprocity and symmetricity, symmetrical properties. So these are the headings you can see here. So write neatly the first one, parameters. So before going into this, we can tell about one thing. So already we tell that 4 combinations, right? That is 4 variable v1, v2 and i1, i2 combined into 2 equations. So that 4c we can get 6 equations. So that will be the combination like 6 equations. 4, 5, 6. One will be v1, v2. Then i1, i2. Tell me other combination v1, I2. Yeah, I1, V2. Then what are the other possibilities? I1, V1. And the sixth one will be your I2, V2. So these are the 6 combination. Let it be each combination will be the each parameters. So for example, the first one. So see, this is the concept. So okay. The first one. What is the first concept you know? Z parameters. Z parameter. What is the Z parameter name? Impedance. Open circuit impedance. Okay, we can see discuss deeply in further lectures. Yeah, so let us see the overview of each parameters. So Z parameter means V1, V2. So definitely output will be I1, I2. We can write V1, V2 will be equal to V1. It is a Z parameter. So use the word Z11, I1 plus. What is the second one? Z12 Z12 I2 and followed by V2. Then can you tell me the further equation? V2 will be equal to, yeah, 1 1 1 2 is over. So definitely Z21 I1 followed by Z22 I2. So this is the equation. Yeah, and matrix. Matrix is nothing but Z will be equal to, what is the matrix format? Z1. We already know Z2, Z2. Clear? And reciprocal theorem. Reciprocity theorem, what is mean by reciprocity? If it obeys the reciprocity theorem, we can tell as a reciprocal theorem. So nothing but Z12 will be equal to Z21. And second one will be symmetricity property. Z11 will be equal to Z22 because one of will be the mirror image of the second of. So this is the first parameter. So can you tell me the second one? Second one will be the Y parameter. So if it is open circuit impedance for the first name in, second one definitely will be a short circuit admittance. It can be represented by I1, I2. I1, I2, and this will be a V1. Definitely V1 and V2 will be that. It is not input and output, sorry. So we can tell in this word. Don't tell it is a input and output. You can use a word instead of this one. Express and in terms of. Okay, so don't use the word input and output. You can use the word express. Express in terms of and in terms of. So now it is correct. So don't tell it is the input and output. You can use the word. And I1, I2, V1, V2. Can you tell me the equation? Who will be a left hand side? Yeah. I1, I2 will be the left hand side. See, this column will be the left hand side and this will be your right hand side. Both I1 and I2 will be the right hand side. So see, I1, I2 will be equal to, it is Y parameter. So use the letter Y. Yeah, very good. So use the letter Y. 1, 1. What is the word? V1. Very good. Plus Y12, V2. And here it is Y21, I1 plus Y22, I2. Yeah. Write the matrix. Y11, Y12, Y21, Y22. Yeah. Then followed by reciprocity. Can you tell me the reciprocal? Y12. Yeah, Y12 will be equal to Y21. And the last one will be, Y11 equal to Y22. Are you understand the two parameters? So out of 6, we can use for the 4 parameters. So 2 parameters will be not there in your. So see, you can in the 3 parameters. Okay. Okay. Third one. The third one. Can you remember the third one name? Yeah, third one is nothing but a transmission parameter. Very, very important parameter. Transmission parameter. Okay. Letter A, B, C, D. So here the combination is V1, I1. And what will be the output? V2 and I2 because V1, I1 is already in job. So now V2 and I2 will be that equation. So tell me the equation. V1, who is the left hand side? V1, I1. What is the equation? It is using the letter A, B, C, D. So previously it is a single letter Z, Y. So that's why you are using in the matrix format Z11, Z12, 2, 1, 2, 2. You make Z into a 4 parameters, 4 types. So here already it is having the 4 letters. So you can use the 4 letters. So A letter, A into what's the letter? V2 and one more speciality of this parameter is inside all this 4 parameter, all the 6 parameter you are using plus symbol in between, but only the transmission and inverse transmission you are using the letter minus AV2 minus B into I2 followed by I1 will be equal to C letter C into V2 minus D into I2. So this one. And what is the matrix letter? That 4 members who are A, B, C and D and followed by your parameters name is, that is your reciprocity. Reciprocity is nothing but AD minus BC will be equal to, this is the important 2-mark question always asking in all the competitive exams. AD minus, what is the reciprocity theorem or find the reciprocity of transmission parameter. AD minus BC equal to 1 and it is equal to A equal to D. Clear? A equal to D. This is the symmetrical property. So once you complete once you sum the transmission parameter, it is easy to understand your inverse transmission parameter. Letter is A dash, B dash, C dash, and D dash. And what is the letter you are going to use? Previously it is V1 I1. Yeah, very good. So inverses will be V2 I2. V2 I2 is coming this side, means this will be V1 and I1. And can you tell me the equation? Left hand side will be V2 I2 will be equal to, what is the letter? A dash. So don't write A letter, it is A dash. A dash into V1 minus B dash into I1. Or you got the answer, minus B I1, and I2 will be equal to C into, that is C dash V1 minus D into I1, that is D dash into I1, and this matrix will be A dash, B dash, C dash, and D dash. Very good. Okay. And here AD minus BC is equal to 1 means what is the reciprocity theorem for inverse? Yeah, very good. A dash, D dash minus B dash, C dash will be equal to 1. The same letter you have used the apostrophe, and symmetricity will be equal to A dash will be equal to D dash. This is the fourth one. So only two more concepts will be there. Who are the two numbers? So one will be the hybrid, and second last one will be the, okay, continue. The fifth one. Fifth one, hybrid parameters. Hybrid letter is H. Yeah, very good. And the combination will be, what is the combination for hybrid parameter is V1 and I2. V1, I2. So what will be the answer for here? V1 is already over. So V2, comma I1. Can you tell me the equation? V1, who is your left hand side? V1, I2 equal to, what is the letter you are going to use? Only the letter H. So you can make it as 4. Make it 4 by means of matrix. So H11. What is the letter? B2. And here what is the symbol? Plus. Yeah, very good. Only the transmission and inverse transmission is minus. Remaining everything will be the plus. H11 is what? So H12 I2. Sorry, I1. Here and here H21 V2 plus H22 I1. And tell me the matrix, the four letters. Yeah, H11, can H11, H12, H21, H22, and the symmetricity property and reciprocal property. So it is little bit different when compared to all others, because reciprocity is H12. H12 will be equal to minus H21. Little bit different. H12 equal to minus H21, and here del H will be equal to 1. It is a symmetricity property. That is a little bit difficult to understand because it is easily forgettable. So that's why I repeatedly insisting H12 will be equal to a minus H21. Can you remember what is the symbol of del H? We are using the matrix, and del means nothing but, yeah, determinant. Determinant value is H11 H22 minus H12 H21. So that is the determinant value. And the last one, sixth one, you itself can write. What is the name? Yeah, inverse hybrid. What letter? We are using the G letter. V1 I2 is for hybrid. So definitely I1 V2 is for inverse hybrid. And this letter will be V1 and I2 is the letter. Tell me the equation. Left will be I1 V2. And what is the equation? It is G, only one letter. So you make it as 4. G11, G21, and here. So followed by, tell me the what is the letter? G11 V1 plus G12 I2. So you can frame that equation. Matrix will be G11, G1, G21, G2. Okay? And tell me the equation. It is same as a hybrid. G12 will be equal to minus G21, and here G will be equal to 1. So I am another time I am saying that del is nothing but the, okay, yeah. Okay, these are the topics. So introduction of two-port networks. So let us see what are the things we are seeing. Clear? So now initially start with our unit 5, two-port network. Two-port is nothing but a pair of a node where voltage is connected, two voltage and two current. These are the real-time application, communication network, electronic power, transmission and distribution. And we see that two types of single port and double port. And two port network is nothing but having four dots, and KCL if you are applying I1 equal to I1 dash, I2 equal to I2 dash. If the problem comes under one port, we can use Thevenin and Norton's theorem, and two port network we can use S domain. And after completing this, we discuss about the combination of parameters. So there will be a 4 combination writing in 2 equations. So let it be the 6. So one and one with the help of the 6 parameter, 6 combination, we can write that z parameter y a b c d h a dash b dash c dash d dash g. So from 4 only it comes under your syllabus, and we discuss about two important 2 mark. Let it be symmetrical means it is a mirror image, and reciprocal means it must be obeyed the reciprocal theorem. Then along this tabular column, you can easily achieve anything. So first one will be a Z parameter, also called open circuit impedance, V1, V2, I1, I2, and the equation matrix format reciprocity matrix. So see, Z parameter is same as Y parameter, only you are changing the letter Y, and the input output, that is expressed and in terms, will be the different. Once you strong in Z, you can write Y. Once you strong in ABCD, you can write A dash B dash. And once you strong in hybrid, you can write G, that is inverse hybrid. Okay. So okay, thank you students. So revise each and every concept daily. Then only you can be a strong. Clear? Okay, thank you.